In the following series of videos, I'm going to introduce a new concept which is going to build on things we've worked with up to this point. It's an idea known as power series, and this is really going to take us into an entirely new area of mathematics. It's something that's normally discussed at the end of Calculus BC. It's developed using calculus. However, most of the manipulations, most of the writing of functions, most of the different applications are things you can do with an algebra background. And specifically, they connect really closely to the things that we've been doing recently with series. So I'm not going to be able to show you everything about how these work or where they come from, but we are going to be able to work with them pretty closely. So as kind of a lead-in here, what is the concept of a power series in the first place? Well, if you're working along with the packet that my pre-cal class is working with, I kind of introduced the idea. If you think back to working with trig identities, for example, of course we know how to find the sine of 30 degrees, we know how to find the cosine of 45 degrees, we can find tangents of different angle measures, but most of those come back to 30, 60, 45 degree angles, or possibly your quadrantal angles, 180 degrees, 270, that kind of thing. Meanwhile, if you remember, at some point we did learn how to find trig values of several other special angles. For example, sine of 75 degrees, we can use a sine sum formula and write it as a sine of 30 plus 45, okay? There are different angles that we can kind of write using a sum or difference of angles, or half angle identities, double angle identities, those sorts of things. And we can find other ways to evaluate those. But if you think about what your calculator's doing, if you take the sine of 72.341 degrees, how's your calculator coming up with that? It's not linear. There's not like a slope. There's not an easy way to kind of flesh that out. And that's a real challenge. How does your calculator find something like e to the 2.59 power? How does your calculator find something like the cosine of negative 343.1 degrees? That sort of thing. So what we're really going to be looking at with the idea of power series is the idea that polynomial functions are often very simple to work with. And we're going to find this out from a calculus standpoint as well. Okay? Non-polynomial functions are very often very difficult to work with. Okay? Now, polynomial function, what am I talking about here? What I'm talking about when I refer to a polynomial function is a function that is a sum or difference of terms that merely have constant values and whole number powers of x. Okay, so for example, x squared plus 5x minus 7 would be a polynomial expression. Okay, we have whole number powers of x. Okay, 3x to the 4th minus 7x squared minus 6x plus 1. Okay, polynomial expression. All right, what's not a polynomial? Well, sine function, cosine function, your trig functions in general. Exponential functions, 2 to the x, e to the x, natural log functions, basically everything that's not written in this kind of a form, okay? Even things that might look like they would be classified as polynomial functions for our purposes are not going to be classified as polynomial functions. So for example, if you have x to the negative 3 power, that's really 1 over x cubed. That's a fraction. That's actually a rational function, okay, which actually some rational functions will be able to be written as polynomials, but not this way, okay? The square root of x, that would be x to the 1/2 power, that's kind of going to be a special case as well. So everything we're going to be dealing with are going to be whole number powers of x. And so as a result, what we're going to be doing is we're going to be taking functions, maybe something like, maybe my function is f of x equals sine of x. And the idea of a power series would be that we're trying to find a way to write this as a polynomial, but it may have infinitely many terms, okay? And so what we're essentially saying is, maybe I'll call this p of x, the power series representation of sine of x. So if I'm going to write a polynomial function that acts like the sine function, okay, it might have a constant value. Okay, so a lot of times we'll call that C sub 0 or C naught. Okay, we're starting out, maybe it's 5 or 1 or something like that. Okay, there may be an x term. Okay, that x term may have its own coefficient. A lot of times we'll use C sub 1. Okay, it may have an x squared term. Okay, and it'll have its own coefficient. We can call that C sub 2. Okay, sorry, x squared term. It may have an x cubed term, okay? And the point is, we don't know what powers of x might be required. I might have to have x to the 15th power or an x to the 129th power or something like that to be able to represent something as complicated as the sine function in a polynomial form. And again, there's a lot of calculus in the background of why we're allowed to do this. So again, for those of you who are not in my pre-calc class watching this video, you may have to go watch some other calculus-based videos to see why this actually works the way it does. And for those of you in my class, obviously, you'll learn that next year. Anyway, so these are actually going to be infinite series. These are series that can go out infinitely high to infinitely high powers of x. The other thing is, you're never going to actually be representing the exact same function with a series. These are really going to be approximations of the original function. And the idea typically is going to be that as you write more terms, you're going to get closer and closer and closer to something that will behave like the actual function, okay? In a lot of cases, it's only going to behave like the actual function at a particular point. So maybe like we'll have a function that for values near x equals 0 will behave a whole lot like the sine function. And then there are ways, if I want information about sine of 17 degrees or something like that, there are ways to write a function that would behave like the sine function near 17 degrees and that sort of thing. Anyway, getting kind of off in the weeds here. Most of those things will be dealt with in calculus, but that's kind of the background. Taking a non-polynomial function, trying to find a polynomial that will basically represent that function or at least approximate that function, but that will behave in the same way as the function near certain values of x, okay? So that's where we're headed. That's kind of a lead into the idea of power series. And in future videos, I'm going to take a look at some specific examples. So I'll see you there in those videos.